Okay, so I would like to thank the organizer for setting up this nice conference and for giving me the opportunity to present my work here, together with Kars Hommes from the University of Amsterdam. And what we would like to be talking about today is about heterogeneous expectations and the financial crisis. So we have a heterogeneous expectation model, which already discussed before by George Evans. And we focus on the financial crisis, so we estimate the model on S&P 500 data, and we want to look at what the heterogeneous agents have to say about the financial crisis. So my first slide is a nice continuation of the previous two talks. So what we are doing in this paper is a heterogeneous learning model. So it has some it's similar as the adaptive learning, that it deviates from the rational expectations hypothesis, which presupposes homogeneous and model-consistent expectation of the agents, because obviously we all know that often leads to, it doesn't include any uncertainty in the model, and it makes it difficult to explain certain things. And as was explained before, the adaptive learning literature assumes agents are learning as econometricians, so they have a perceived law of motion and they update the parameters of their perceived law of motion. What we do here is that we have agents they can choose between different forecasting heuristics. They're very simple rules to forecast prices. And they learn as decision makers in complex environments. So they may be very simple rules, but if one of those rules performs badly, then they switch to better performing rules. So the choices from the set of rules are updated every period. So that makes that they cannot make huge mistakes. And the advantage of that approach is that it can be supported by micro-level evidence, as some of the things I've put up in this slide. So for example, survey data, already discussed yesterday, that from survey data we know that investors have heterogeneous price expectations, sometimes with time-varying fractions. And also we learn from experimental data. We have a laboratory experiment in Amsterdam where human subjects are entering and try to predict next prices. Then we see that their behavior can be well described by a number of simple linear rules of thumb. And finally, also by empirical data, that, for example, in mutual funds and pension funds, that we see that the good performers, they attract more funds. So if in the past some of the funds perform poorly, then they will get less money in the future. So that's also important in our model that there are different rules, and if one of the rules performs better in the last few periods, then it will attract more agents, and more agents will choose that rule. Okay, so what's our approach? We use a quarterly data set from the S&P 500 from after the World War, post-war, and we also include the crisis. So in previous work, it was a yearly data set, and it was not the crisis was not included yet. And our empirical approach consists of two steps. So first, we compute a fundamental value of the stock market index based on dividend trends, dividends and interest rates. And then we estimate the heterogeneous agent model on the deviation from the fundamental value. So this is also the approach was taken before. And of course, you can always argue about what is the right fundamental value. It's very difficult, but what we will assume, an important aspect of the fundamental value is that we have a constant risk premium. And so we do, of course, if we allow for different risk premia, we can also explain the data, but we keep it fixed, and this will allow us to focus on the possible time variation in investors' expectations. Okay, so what are the main findings of our paper? We find evidence for expectational heterogeneity in the post-war data. Because the estimation is not completely evident, we use Monte Carlo simulations to check the validity of our estimations. And our model predicts that temporal bubbles, which are triggered by fundamentals, can be amplified by trend following behavior. So one of the rules would be trend following rule. And if by some shocks that trend following rule seems to be well performing, then it will attract more agents, and that will lead to a self-fulfilling effect. The financial crisis was amplified by strong belief of investors in mean reversion of their overpriced stocks. So they believed that the prices were overpriced, and when the big shock hit the economy, then all agents reacted to that. And we use out-of-sample predictions to make clear that the depth of the crisis is much less surprising if we allow for heterogeneous learning. Okay, so by the way, if you have questions, you can also ask them in between. I'm very happy to react on it or suggestions. Okay, so agents in our model are, of course, concerned with future excess profits. So their income of their stock that they buy is PT plus 1 and YT plus 1, the dividends. And they look at this profits relative to investing in the risk-free asset, which gives rate of return R. So their pi is the number of assets they buy, Z, IT, times their excess profits, RT. And then we use a standard asset pricing equation, which can be derived from mean variance maximization, where the price today depends on the expectations of the future price and the future dividend. The only difference here is that ET bar denotes the average expectation. So in principle, they can have different expectations, but it should hold that their average, in average, that is their prediction. And R then, the required rate of return includes both the risk-free rate and a fixed risk premium. Okay, so agents believe in stock dividends with a constant growth, so they can estimate the growth factor G from our observations. And then we can rewrite the pricing equations in terms of the price-dividend ratio, dividing by YT, and an effective discount rate. So delta T is the price-dividend ratio, and it again depends on the expectations of the future price-dividend ratio. And then you can calculate the fundamental price-dividend ratio under rational expectations if all their expectations are correct and they're constant every period. So this is 1 plus G divided over R minus G. Okay, so this is what we get when we do that on the data. So we find R of 1.24% per quarter and a G of 0.4% per quarter. And find a fundamental price-dividend ratio of around 30. And with this fundamental ratio, we can find the fundamental value of the stock index. So we see that up to 1990 there were some deviations from the fundamental value, but after 1990 there was a consistent overpricing. You see the dot-com bubble and the crash after that, and also before the financial crisis in 2008 there were some consistent deviation. And this fundamental value that we find, that depends on our assumption of a constant risk premium, of course. So here I've depicted them. So the fundamental value is this ratio, 1 plus G over R minus G. So and R and G are, they're from the data.
Is it a sample average of past growth?
Yeah.
And real interest rate?
Yeah, so no, but R also includes the risk premium, the fixed risk premium. So this is the average dividend yield plus the risk-free rate.
People could say the past sample may not incorporate things about the future.
Yeah, actually here we do it over the whole sample. So we compute the R and G over the whole sample and we keep that fixed over the whole period.
Is the fundamental
Yes, sure. But I think the most important assumption is that we have this fixed risk premium. And so you could also look at the deviations over time over R and G. So this is the static Gordon model, and we also later looked at the dynamic Gordon model, but actually then the deviations from this fundamental value are really small. Okay, so this is again the picture in terms of the price-difference ratio. And we see after 1990 there was a consistent overpricing, systematic overpricing. And now with our heterogeneous agent model, we want to explain these deviations from the fundamental value. Okay, so in terms of the deviations xt from the fundamental value delta star, we have that with this one step ahead pricing equation, we should have that the deviation today depends on the average expectations of the deviation of tomorrow using the effective discount rate, R star. And those expectations, they are simple expectation heuristics. And the simplest example are just two linear rules, linear in the last observation. So we assume that at period t only prices up to t minus 1 are observed. And then expectations phi h times the last observation are the linear heuristics. And this captures the typical opposition of fundamentalist and chartist. So fundamentalists, they believe that the price-difference ratio will return they will return to the fundamental value. So they believe that this difference should be decreasing. And chartists, on the other hand, they believe in a trend. They are looking at trends. So if they foresee that it will be bigger. Okay, so they use realized profits to choose between the different expectation rules. And we also include, in contrast to previous literature, memory in the performance measure. So a performance measure is U for every rule H. So that depends on the last performance with a fraction omega, and the new profits are added to that with factor 1 minus omega. And then using that performance, we look at the fractions using a multinomial logic model, as in the Brock-and-Hammers framework. With this parameter beta is the intensity of choice. So here I use beta for a different parameter. And again, if beta is 0, then with only two rules, they both have fractions 1/2. And if the beta is going up, then more agents will go to the better performing rule in the past. So in the limit to beta infinity, they only choose, the fractions can be only 1 and 0. Okay, so econometrically, we have an AR-Mon model with time-varying coefficient. This is this phi t. And we can interpret that as the average market sentiment. So it can be bigger than 1 if a lot of agents believe in a chartist rule. If the N2T is very large, there's a number of chartists. And it can also be much smaller than 1 if this fraction of fundamentalists is high. And the fractions depend non-linear on past realization. So here I've just indicated this is a function of all past realizations, x, deviation from the fundamental value, and the 4 parameters. And now we will estimate the 4 parameters on the data. So this is what we get. And one of the typical problems in this type of models is that you have insignificant beta coefficient. So beta is again the intensity of switching. So it appears to be not significantly different from 0. But if that is the case, then you cannot, then there's no switching. So you cannot discriminate between phi 1 and phi 2. So this is the potential problem. And also, if you have a little bit different model or a little bit different data, then you can have different beta parameters which affect the other coefficients. So for this reason, it has been recommended to normalize beta as 1. We can estimate the model again. We just put in beta as 1, and then we get the following results. And I will return later to this problem of beta non-significant, and we'll show that this insignificance doesn't necessarily mean that there is no switching in the data, but that means that the test for seeing whether it's bigger than 1 has a low power. It's particularly low power in this situation. Okay, so we found 2 different regimes, phi1 and phi2, which are the different rules for predicting the next price. What's important here is that we have evidence for heterogeneity because the difference is significantly different from 0. And we also have, like we thought before, we did not impose that, but we find one parameter smaller than 1 and the other bigger than 1. So this is important evidence for heterogeneity in the data. We see that there are different regimes can be there. Secondly, we also find significant memory. So we have memory of 0.8. And that's very important for estimating this on higher frequency data. So before it was estimated on yearly data, and there you did not need this memory, but here you do. And we see that most information is based on the last year's observation because after 4 quarters, you don't remember a lot of the information you got. So these are the 2 results we get from this estimation. Okay, so as a benchmark, we also estimated just a simple AR1 model. And this gives a coefficient which is between the 2 other coefficients in the heterogeneity model, so it's 0.986. And there we encounter that there's possible non-stationarity because the Dickey-Fuller test does not reject the null hypothesis of phi is 1. So we estimate it's smaller than 1, but we cannot be sure from this regression that it's smaller than 1. And then, of course, with non-stationarity and the results do not hold anymore. And we also go back later with Monte Carlo simulations to see why this is the case. Okay, so we now treat the estimated equations as data-generating processes. So for the heterogeneous agent model, we have this time-varying coefficient, phi t, which is between 2 borders, and is updated every period by this, based on the past observations, past realizations of the data-generating process by beta is 1, and the memory omega is 0.8. And we also have a simple AR1 model where we just run this AR1 model. Okay, so then again, under these different data-generating processes, we can estimate different models, irrespective of what is the true model. So then we have different tests. We look at 3 tests, and we have the state of the null hypothesis. So for example, you see that we have 2 stationary processors which are simulated. So the null hypothesis of a unit root is always false, but we can still look for a unit root, and maybe we find that we cannot reject it. And of course, for the heterogeneous model, for the heterogeneous data generating process, we have indeed that there's heterogeneity and switching. So the second and the third column, they in that case, they have false null hypothesis. But for the simple AR1 model, they're true. So what would we do if, what happens if we simulate this data generating process for a long time? So first we look at just realistically large sample size of 5,000 quarters. And using a nominal significance level of 5%, we check whether the p-value of each test is below this alpha, and then for many times, many replications. And what's interesting that even for this large sample size, this test for beta 0 lacks power. So we see that in 12% of the replications, we do not reject the null hypothesis of no switching, even though we know it's false. But the other tests, they are asymptotically working correctly. So for example, the test for homogeneity, it always rejects when there is heterogeneity, and it never rejects when there's homogeneity. Okay, so now what happens if we use the actual sample size of 252 periods? And there we see that the test for no switching doesn't work at all anymore, and we never reject it, even though we know it's true. And also for unit root, we have very low power. And what's interesting is that for the heterogeneous model, we have even lower power, lower than for the AR1 model, and also lower than the actual for the actual alpha we're using, the nominal significance level. So on the other hand, the test for homogeneity works quite well also in this small sample. So the fact that we find that the null hypothesis is rejected points that the heterogeneous agent world is much more likely than a linear homogeneous world. So the estimation results are as expected under heterogeneous learning. So this was the estimation part of the talk, and also testing or validating the test we used with Monte Carlo simulation. So now, having this model, what can we do with it, and how do we interpret it? So these are the estimated fraction of fundamentalists over time from 1950 to the end of the period. So you see that up to 2003, the fraction was around 1/2. There was no big difference between the two rules, and they performed equally good. But with the dot-com bubble, the trend-following rule, the Chartist rule, was getting more followers, and the number of fundamentalists went down. And then after 2003, in general, the fundamentalists dominated the market. So it was always, all the time, bigger than 0.5. And also you see before the Lehman shock, thank you. Before the Lehman shock in 2008, the number of fundamentalists was already around 100%. So this might have amplified the crisis.
So what explains the huge change in 2003?
So that was the end of the bubble, and then the bubble crashed. So
why did it switch to almost 100% from almost 0?
yeah, apparently because the differences in profits are so large that it was required for this beta is 1 to switch to the other rule. Yeah. And if you have a lower beta, then the switch would be not as high. But for this parameter, we do find that. So we do not explain why the bubble ended as it appeared. That was a shock, but we can explain why the few shocks in the beginning of the 1990s could be amplified by the number of Chartists in the market, and we can also explain why in 2008 the shock was so persistent because of the number of fundamentalists in the market. But Okay, so this is the mirror image then of the number of fundamentalists. So this is the average market sentiment, phi t. And here you see the definition again. And you see again that for most periods it's below 1. But in this period from 1995 to 2000, it was bigger than 1. And so that's why the deviations are getting larger and larger from the fundamental value. And we got this consistent overpricing, which stayed longer there. Okay, so actually I'm already almost done. I want to give just some out-of-sample predictions. So now we estimate the same model up to 2003, and we then let the model run, and we look for different quantiles of the predicted values. So the big dots are the median predictions of the model, and you see the 95% and the 5% percentiles. So here, this is for the linear AR1 model, and of course the prediction is also linear. And in that sense, the depth of the crisis was very unexpected, and it was much larger. It was much below the 5% percentile. And also do this for the heterogeneous agent model. And then, because in 2003 the number of fundamentalists was already high, you get much lower predictions of the model, and the depth of the crisis was not that unexpected. And but what you also see is that the predictions are non-linear. So in the long run, it can be that a new bubble occurs. It can go up again. But this was the prediction of the heterogeneous agent model from the price difference ratios. Okay, so this is what I wanted to say. We estimated the heterogeneous agent model on stock price fluctuations using this model. And we find evidence for expectational heterogeneity. We find that temporary bubbles triggered by fundamentals can be amplified by trend following behavior. And also, it seems the implication of our model is that the financial crisis was amplified by a strong belief of investors in the mean reversion of overpriced stocks. Thank you.